Hello everyone, welcome to my channel Physics with Bhatt. To learn concepts of physics, subscribe this channel and press the bell icon button to get notified for every new video lecture. Hello everyone, I hope you all are doing well. In the previous series of video lecture for wave optics, we discussed so many aspects and important topics. From today onwards, you will be getting the video lectures for the chapter atom and nuclei. In this series, we will cover all the topics. So today I brought a very important topic that is helpful in board examination as well as the competitive examinations also. So today's topic is Rutherford's atomic model. Before discussing the Rutherford atomic model, we should understand the experiment which was performed by his two associates Geiger and Marsden. That is known as Geiger-Marsden experiment. They forwarded their observations to the Rutherford. Rutherford analyzed them and tried to explain about the atomic model. So let us begin first with the Geiger-Marsden experiment. Geiger and Marsden demonstrated an experiment to study atomic structure. What they did, they took a very simple arrangement. In this experiment, a beam of alpha particles is made to fall on thin gold foil and scattering of alpha particle is observed. So basically, this Geiger-Marsden experiment is the experiment of scattering of alpha particles. Let's see the experimental arrangement. You can see here the source of alpha particle which is placed in a chamber, and the alpha particles emitted by the source are allowed to fall on the screen. That screen is made of zinc sulfide through the gold foil. You can see here the gold foil is shown. We can have another look of the experimental arrangement that will clear you microscopically what is happening here. So we can compare both the diagrams together. Here is the source of alpha particle. The emitted alpha particles are converted into a beam of alpha particle. You can see here the beam of alpha particle. The beam is propagating along a single direction. It is done by the collimator, and the collimator is lead bricks. These lead bricks are used to collimate the emitted alpha particles into the beam of alpha particles. When this beam of alpha particle falls on the gold foil, which is very thin, you can see here, the order of thickness is of 10 per minus 6 meter to 10 per minus 8 meter. We have a movable screen which is made of zinc sulfide. When this screen is exposed to the alpha particles, or we can say when alpha particles strike to the screen, then scintillations are produced. So number of scintillations, we will observe what happens to the number of scintillations. This screen is moved in circular path all around the arrangement. It is observed that when the screen is just behind the gold foil, then number of scintillations are maximum. When we talk about the angle, then almost this angle is 0, and this angle we are considering with respect to the direction of propagation of, or the line of propagation of beam of alpha particles. So as we increase the angle, the number of scintillations decrease, that you will see in the observations made by Geiger and Marsden. So I hope the experimental arrangement is clear. We are having source of alpha particle. These are lead bricks known as collimator, and the beam of alpha particle is falling on the gold foil. It's very thin, and the scattered alpha particles we are observing with the help of zinc sulfide screen. When the alpha particle strikes to the zinc sulfide screen, a number of scintillations are produced here. So let's see what are the observations made by the Geiger-Marsden. The first observation made by them is just behind the gold foil, maximum number of scintillations are observed. As I told you, we will increase the angle with the reference line of the propagation of beam of alpha particle. Then for the small angle or 0 angle, the number of scintillations were maximum just behind the gold foil. The number of scintillations decreases with increase of angle of scattering. जितना angle of scattering को हम increase कर रहे हैं, the number of scintillations are decreased. Only few scintillations are observed at the angle of 180 degree, approximately 1 out of 8,000. So if angle of scattering is increased, it means we are revolving the screen with greater angle, then the number of scintillations are very few, and for 180 degree very less number of scintillations are observed. So on the basis of this observation, which were forwarded by Geiger and Marsden to the Rutherford, conclusions were made by Rutherford, and these conclusions are like this. Most of the alpha particles pass through the atom due to lot of empty space in atom. If we connect the first observation, that shows since number of scintillations are maximum just behind the gold foil, it means most of the alpha particles pass through the gold foil, that is most of the alpha particles pass through the atom. So lot of empty space is available in atom. Entire positive charge must be at single point because a number of scintillations are decreasing with increase of angle of scattering. This was the observation made by Geiger and Marsden. If we increase the angle of scattering, then number of scintillations are decreasing. So Rutherford concluded that the positive charge must be at single point. That's why it is happening. Another conclusion made by Rutherford was only those alpha particles which are scattered at 180 degree, which are in head-on collision with the positive charge of atom. The third observation was only few scintillations were observed at 180 degree. The reason behind it is those alpha particles which are incidenting just head-on and interacting with the positive charge, they are sent back along the same path in opposite direction. So in this section we discussed about the observations made by Geiger Marsden, and on the basis of those observations, conclusions made by Rutherford. On the basis of these conclusions, he put forward his atomic model. So we will discuss this model in detail. Entire positive charge of atom is lying at the center of the atom, and that center of atom is termed as nucleus. So the credit goes to Rutherford for discovery of nucleus. It was very challenging. So many scientists tried hard, but they could not find the proper location of the positive charge. Rutherford was the first one who suggested that the entire positive charge is lying at center of the atom, and this center of atom is given the name nucleus. So this is the very important outcome. Most of the mass of atom is concentrated at nucleus. The reason behind it, since positive charge is lying at the center, so and electrons are very light particles, so the mass of atom is almost concentrated at the nucleus. A lot of empty space is available in atom, and what is there in that empty space? In that empty space, electrons are spread all over the space available in the atom. Negative charge is present in terms of electrons, and all the electrons are not stationary, they are revolving around the nucleus in their respective orbits. So negative charge is not confined at the single point, it is present in terms of electrons, and these electrons are not stationary, they are revolving around the nucleus in their respective orbits. अपने अपने orbits में revolve कर रहे हैं. Atoms are electrically neutral. This is another important aspect. Overall, the atom is neutral because it has equal amount of positive and negative charge. Size of nucleus was also suggested by Rutherford, and he suggested that the size of nucleus is approximately 1 upon 10,000 times the size of atom. He just suggested this idea by his observation. 1 out of 8,000 alpha particles is scattered at 180 degree. He roughly approximated that the size of nucleus is around 1 upon 10,000 times the size of atom. We will meet very soon in the next video. Till then, keep watching, keep learning.